Hello everyone, welcome to this video on polynomial evaluation. In this video, we will explore the concept of polynomial evaluation in more detail and learn how to evaluate polynomials in computer using Python programming languages, developing its algorithm and implementation. So let's start with the meaning of polynomial. What do you understand by the polynomial? So basically, polynomial is a sum of several terms that contain different powers of same variable. That is, for example, we can take x squared plus 3x plus 2, that is any quadratic equation, or a cubic equation, that is x cubed plus x squared plus x plus 0 with any kind of coefficient. So that is sum of several terms that contain different powers of same variable. Now let's come to the introduction of polynomial evaluation. What do you mean by the polynomial evaluation? So basically, polynomial evaluation refers to process of computing the value of that polynomial expression at a given point or a set of points. So whatever the value is, suppose it is same variable with the different powers. So at a particular point x, that is if we say x is equal to 2, so we will put the value of x is equal to 2 in that expression, and we will find that value of that expression fx or px, whatever the name is given to that expression. So that is basically the meaning of polynomial evaluation. As in this diagram we can see what is coefficients, what is degree, and what are variable. So an minus 1, an minus 2, up to the a naught or a 0, whatever you want to say, whatever you want to call it. So these are called coefficients. And a, and the largest degree and the largest exponent of the expression is known as degree of that expression, degree of that polynomial. So here the largest exponent we can see is x to the power n. So x to the power n is the degree of polynomial, and we can say that px is nth degree polynomial function. Suppose if the largest degree is 3, so that is a third degree polynomial function, that is cubic polynomial. So now let's come to the types of polynomial, that as I gave you examples already, that is linear polynomial, quadratic polynomial, cubic polynomial. And linear polynomial, the degree is 1, quadratic polynomial, the degree is 2, and cubic polynomial, the degree is 3. So here we are going to create algorithm for evaluating such polynomials. So there are two methods to evaluate any polynomial. One is brute force method and one is recursive method. So let's just understand what is the brute force method is. Like in force method, we just continuously we just continuously add the terms of the polynomial. That is just basically addition one by one in a loop, but it is very very lengthy process, so recursive process is very much given preferences over that brute force method. But first we will learn about brute force method, then we will come to recursive method. So, for brute force method, to make it more simple, let's take the expression px is equal to a naught plus a1x plus a2x up to the an xn. That is the general expression of any polynomial, where a naught, a1, a2 up to the an are coefficients of their respective x with their exponent. So if in this expression we will just take the x common from this expression, so when we take x common from this expression, we have px is equal to a naught plus x, in the bracket we have a1 plus a2 plus x plus up to the an x to the power n minus 1. Then what we will do, we will continuously take the x common from this expression continuously, and up to the end we will reach the expression where px would be equal to a naught plus x bracket a1 plus x bracket a2, and up to the x where last term will would look like x plus a n minus 2 plus x a n minus 1 plus x a n. So why did we do that? We do that so that as you can see a common common term, or you can see a pattern here. So the pattern is a n minus 1 plus x a n, that is a term, a coefficient plus x multiplied by another coefficient. It is a general, as you can see, it is a general pattern we can see here. So if we add, if we give one exponent or variable the value of this last term and keep adding on these last terms up to the n steps, then we will get the value of the polynomial px. So let's come to the for this, it is very difficult expression to understand this expression. So let's take one example. Suppose we have expression px is equal to 4 plus x plus 2x square plus 3x cube. So now we will take second step, that is px. We will take x common. So 4 plus x in bracket we have 1 plus 2x plus 3x square. Then again we will take x common. So the next term we have, next expression we have px is equal to 4 plus x. In bracket we have 1 plus x, and then again we have one bracket 2 plus 3x. Now we cannot further, we cannot take out x common further. So we have a so this is our last expression, px is equal to 4 plus x in the bracket 1 plus x in the bracket 2 plus 3x. And we can compare it to the general equation. Then we can see that x naught here is our 4. No, a1 here is our 4. I'm sorry. A naught is 4, a1 is 1, a2 is 2, and a3 is 3. So these are corresponding coefficients, and there is and their values and this table given below. A naught is equal to 4, a1 is 1, and a2 is 2, and a3 is 3, by comparing this equation with the general equation of polynomial. Now let's come to the most awaited part, developing algorithm for this brute force method of evaluating polynomial. So in this brute force method, what we will do, first we will take two inputs, that is x, the value of, suppose we are evaluating the polynomial at a particular point at x. So we will take that point x and then degree of the polynomial, that is highest exponent in that expression. So we'll take its degree, and we will create one loop, and read for first we will read all the coefficients of the x. For if it's x naught, if it's x, so we will take the exponent of x, that is a1. If it's x squared, then we will take coefficient of x squared, that is a2. Coefficient of x1, that is x to the power 1, that is a1. Coefficient of x cube, that is a3, and so on. So we will read all the coefficients, that is a in the bracket I, that is ai, and I is basically just nothing, it is a0, a1, a2, a3, and so on. And then we will create a container or a variable where we just continue add on this expression as we created the general term, the last term with the common pattern, that is a2 plus a3x. For this example which we have taken, that is px is equal to 4 plus x in the bracket 1 plus x in the bracket 2 plus 3x, and we compare with the general equation, we will have a naught plus x, a1 plus x, a2 plus a3x. So this a2 plus a3x is our p, matlab, is our last expression, and we will continue add on this expression up to the last. Then we will have the evaluating term. So in p we will add the in p we will add a to the an, that is the a, suppose the degree is 3, then we will have a3, that is we will take the last coefficient. So we will take the last coefficient for, and then we will create one next loop, that is for I is equal to n to 1, we will that is a reverse loop, we will take from I to n, that is from last term to 1 with a step of -1, that is just a reverse loop. And in p we will just do this expression a I minus 1, that a I minus 1 plus x into p, plus x into p. And in this way we will continue adding this in a p, and then after the evaluating we will print p. So if we take a first loop, so in first loop we will have a I minus 1 is equal to, that is a 2, because here I starts with 2, because our degree of the polynomial is 3, so I minus 1 is 2, because it is starting with n, no, so I minus 1 is 2, that is a I minus 1 will be equal to a2, and a2 plus x multiplied by a3, that is p, we already given the value to the p, that is an, so x multiplied by a3, so we have created this term a2 plus a3x, and in the steps. So now let's take a look on the table of loops. So in loop 1 it will be 2 plus 3x, and in loop 2 it will be 1 plus x p1, that p1, and p1 is basically 2 plus 3x. Then in third loop it would be 4 plus x plus p x multiplied by p2, that is 4 plus 1 in the 4 plus in the bracket 1 plus x p1. And what is x p1? As we can see here, our last expression will be 4 plus x in the bracket 1 plus x, and in the bracket 2 plus 3x. That is basically our evaluation of this. Since we talked about the implementation parts, let's implement that polynomial evaluation. First we will take input x and n. X will be the point where we have to evaluate the polynomial, and n will be the degree of polynomial. So n is equal to input, enter the degree of polynomial, and then we will create an array degree, so that we can add all the respective coefficients of x in it, and then we will create one for loop for I in range n plus 1, and n plus is not inclusive, so it will be in range n only. Then degree is equal to int input, enter a dot format, a curly bracket dot format I. Now we will, now that respective a will be added in that degree array. Now degree dot append degree. We use degree 2 times, so it will create an error. So let's just solve this error degree, and we will take this as a rather than degree, rather than using degree. Now we will create a last term, last common pattern, that is p is equal to degree minus 1, that is last coefficient, that is an. Then we will create one for loop for I in range n 0 to minus 1, that is a reverse loop, and p is equal to degree I minus 1 plus p multiplied by x, and this, and in the loop it will be continuously added, and then we will print the result. So now let's just see the errors, and let me just solve the error that is in here. Yeah, now error is completed. Let's run the code. Enter the value of x, so we are entering the value of x here to be, let's say we should take the value that we taken the example previously, so it should be 2, and then they should enter the degree of polynomial, let's say it's 3. Then we'll write a naught, enter a0 a1, and then a2, yeah, and a3, and it will evaluate the polynomial, and the result is 38. Yeah, thanks. Now let's talk about the recursive method, the second most awaited method for implementing Python, implementing in Python, that is polynomial evaluation, implementation in Python, that is. So let's talk about this recursive method. So this first step for our algorithm in this recursive method basically means calling a function within a function to implement certain function. So first step will be, if the degree of polynomial is 0, then return the value of the constant term a0. Otherwise, compute the value of px recursively by computing the value of polynomial of degree n minus 1 by calling the function recursively with the polynomial of degree n minus 1 as argument. Means the function calling the recursive function is calling itself with the argument n minus 1 in this definition, and then computing the value of current term by multiplying the coefficient of x raised to the power degree of term, that is x to the power a degree. Then adding the computed value to the polynomial of degree n minus 1 and return the value of the polynomial px. Now reading the algorithm is again very confusing method. So let's directly jump on the implementation part in Python. Thank you so much. Now let's talk about the polynomial implementation part. So we will first we are first here creating a function that polynomial a and x, where a is a coefficient, n is a degree, and x is a point where we have to evaluate polynomial. If n equal to 1, return a 0, and else return a n multiplied by a to the power n plus polynomial. We are recursively calling it with the argument n minus 1, a, n minus 1, and x. Now we will check is it working or not. We are taking equal to 4, 1, 2, 3, our previous example, and then print polynomial a, comma 3, comma 2. Yeah, that's pretty much it, and that answer is 38. Thanks. So, after making polynomial evaluation easy, now we are going to make polynomial division and derivation easy. Here, we are going to implement we are going to create algorithm for polynomial division and derivation. For polynomial division, we will be dividing polynomial with x minus r. Now, let's proceed. Let's get started, shall we? So for polynomial division algorithm, firstly, we will initialize the quotient polynomial q and remainder r to 0. For each term of polynomial from highest to lowest degree, first we have to compute the value of current term of the coefficient by dividing the coefficient by x minus r, then adding the computed value to the coefficient polynomial q, then compute the value of current term of the remainder by multiplying the quotient of the term by x minus r, subtracting the current value from the current term of the polynomial, and then finally adding the computed value to the remainder polynomial r. The return Now we will return the quotient q and remainder r. So this is the simplest algorithm we can write for polynomial division. It is a similar way how we divide the polynomial with x minus r, just dividing it, and we will get the quotient, and and then we will divide it with the current term, and then we will get the remainder. In the similar way this process goes on, and finally we will get the quotient and remainder by continuously adding their terms and getting their value. Now let's move to the polynomial derivation algorithm, like derivative, for to find the derivative of polynomial, that algorithm. For this we have to initialize the derivative of polynomial d to 0. Second step is for each term of polynomial from highest to lowest degree, first we have to compute the value of this derivative of the current term by multiplying the coefficient with the degree of the term and subtracting 1 from the degree. Then, and after that, after this step, we will add this computed value to the derivative polynomial d. And the last step will be return the derivative polynomial d. It is simplest, these two are the simplest algorithms. We have not done any crazy stuff like we have done it earlier in evaluation. So after understanding the polynomial evaluation, these two are pretty much easiest algorithm we have. Like we can easily understand these algorithms if we have already understood how to evaluate polynomial, like polynomial evaluation earlier that we have discussed. So thank you so much.